Welcome to today's tutorial on Python functions and file handling. If you are just starting with Python or want to improve your skills, mastering these two concepts will make your programming journey much smoother and more efficient. Let's first talk about functions. In programming, a function is essentially a block of code designed to perform a specific task. Functions allows you to group related code together, making your program more organized and easier to manage. Imagine if you had to write the same code repeatedly, this would be inefficient and make your program difficult to maintain. Instead, by using functions, you only write the code once and then you call it wherever it's needed, reducing redundancy and improving code readability. We will explore how to define a function in Python using the def keyword, pass parameters to it and get output by returning values. With functions, your code will not only become more reusable but also more modular. This means you can build more complex applications by combining smaller, simpler functions. Functions also make debugging easier because you can test them in isolation. Now let's shift gear to file handling in Python. Working with files is a core part of many real-world applications. Whether you are building a data analyst tool, a game, or any kind of system that needs to store data, understanding how to work with files is crucial. Python makes this task quite simple with its built-in file handling capabilities. In this tutorial, we will go over how to open, read, write and close files using Python. The open function allows us to access a file and specify the mode, whether we are reading from it, writing to it or appending data to it. After we are done working with a file, we will learn how to properly close it to prevent data loss and avoid consuming unnecessary resources. Together, functions and file handling will not only help your organize code better but also allow you to work with data stored in files, an essential skill for real-world programming. So stay tuned as we dive deeper into each of these topics, and by the end of this video, you will be comfortable using functions to structure your code and handling files to store and retrieve data. Before we dive into the details, let's quickly go over the agenda for today's session. Understanding the structure of the video will help you follow along smoothly and know what to expect. First, we will start with an introduction to Python functions. We will explore what functions are, why they are important, and how they can help you write more efficient, reusable, and modular code. We will walk through the process of defining functions, passing parameters and using return values, which will make your programs cleaner and more organized. Next, we will shift our focus to file handling in Python. File handling is an essential skill in programming as it allows you to read from and write to files. This is crucial for applications that need to store data, work with logs, or process large data sets. We will cover how to open a file, read its content, write to it, and close it properly. We will also discuss the various modes available for file handling like read, write, and append. Once we have covered the core concepts, we will walk through some real-life examples. This will help you understand how to apply both functions and file handling in practical situations. These examples will solidify your understanding of these topics and show you how they can be used in real-world projects. Finally, we will wrap up with a summary of everything that you have learned along with some key takeaways that will help you continue your Python journey. You will leave this video with a solid understanding of functions and file handling in Python. You will be able to implement these concepts in your own projects. So let's jump right into it and get started with the first section, Introduction to Functions. Let's kick things off by talking about functions in Python. A function is one of the most fundamental concepts in programming. In simple terms, a function is a block of reusable code that performs a specific task. Functions allow you to organize your code into smaller, manageable chunks, which not only makes your code cleaner but also easier to debug and maintain. Why are functions so important? Imagine If you had to write the same code over and over again for different parts of your program, it would not only make your code unnecessarily long, but it would also increase the chances of errors. Functions help avoid this redundancy by allowing you to write the code once and call it wherever needed, which is both time efficient and reduces the possibility of mistakes. In Python, defining a function is really simple. You start with the keyword def followed by the function name and parenthesis. After that, you write the code block inside the function. This block of code is only executed when you call the function. Now that we have introduced this call triggers concept the function of functions and the message, let's dive into this. We will dive deeper into how look at an example to understand how they work and handle more in Python. Defining a function follows a simple structure. Remember, first we use the def keyword, which stands for define. After that, we provide the name of the function. The function name is what you will use to call the function later in the code. Function names should follow standard naming conventions, starting with a letter or underscore and avoiding spaces or special characters. After the function name, you will see parentheses. These parentheses can hold parameters, values you want to pass into the function, so it can perform its task. If no parameters are needed, you can leave the parenthesis empty. After the parenthesis, we use a colon to indicate the start of the function body, which contains the code that will execute when the function is called. Let's look at an example of a function with parameters. Here we defined a function called add numbers, which take two parameters a and b. Inside the function, we calculate the sum of these two parameters and store it in a variable called sum. The return statement then sends this result back to wherever the function was called. To call this function, we simply use the function name and pass the values for a and b. This output 8 because we passed 5 and 3 into the function and the function returned to the sum. Functions can be as simple or as complex as needed, and they play a crucial role in making your code more organized and efficient. Let's take a deeper look into functions in Python and why they are an essential part of your programming toolkit. A function is a named block of code designed to perform a specific task. The great thing about function is that once you write them, you can reuse them throughout your program, which helps you avoid repeating code and makes your program much more manageable. Function also allows for returning values. This means you can send a result back from the function to wherever it was called. Whether you are calculating numbers, processing data, or manipulating strings, you can use functions to make your code more efficient and structured. Functions are one of the first steps to writing clean, reusable code. In Python, they are incredibly easy to implement. And as you progress, you will see how they help break down complex problems into simpler, more manageable pieces. Now that we have covered the basics of functions, let's explore the different types of functions in Python. Understanding these types will help you choose the right kind of function for different tasks and scenarios. Python functions can broadly be categorized into two types: built-in functions and user-defined functions. Built-in functions. These are the functions that come predefined in Python and are always available for use. Examples include functions like print, length, input, and type. These functions perform common operations such as displaying output, finding the length of an object, taking input from the user, or determining the data type of a variable. You don't need to define these functions yourself. Python provides them by default to make programming easy. For example, print displays output to the screen, while length returns the number of items in an object, like a list or string. These built-in functions save you a lot of time and effort because they handle common tasks without you having to write the code from scratch. User-defined functions. These are the functions that you define yourself. You can create a user-defined function whenever you need to perform a specific task that is not already covered by Python's built-in functions. User-defined functions allow you to break your code into smaller, more manageable chunks, making it reusable and easier to maintain. Another category of functions are recursive functions, which call themselves in order to solve smaller instances of a problem. Recursion is a powerful technique used in algorithms like factorial calculations and tree traversal. So to recap, Python functions can be built-in or user-defined. Built-in functions save time by offering common functionalities, while user-defined functions allow you to create custom behaviors specific to your application. Whether using built-in or defining your own, functions are essential for writing efficient and organized code. Arguments in functions. Arguments allow you to pass information into functions. There are several types of arguments in Python: positional, keyword, default, and variable length arguments. Positional arguments are passed into the exact order of the function expects them. Keyword arguments allow you to pass values by naming them, so the order doesn't matter. Default arguments let you set a fallback value, so the user doesn't always have to provide it. And variable length arguments using asterisk args or double asterisk kwargs let you accept any number of inputs. For example, you might write a function to greet users, and whether you greet one user or 10, your function can handle it. Arguments make your function versatile and powerful. Return statement. A return statement sends back the result of a function to the place it was called. Without a return statement, your function might do something like print a result, but it won't give back any value you can use later. For example, imagine you write a function that calculates tax on a product. If it just prints the tax, you can't use that value for further calculations. But if it returns the tax, you can store it in a variable and use it to compute the total price. Return statements make your functions not just reusable but also meaningful because they give you data back. Understanding variable scope is key to avoiding bugs. Variables created inside a function are called local variables. They exist only when the function is running. Once the function ends, those variables are gone. On the other hand, global variables exist outside functions and are accessible throughout the program. But be careful. Changing global variables from inside a function can lead to unexpected results unless you use the global keyword explicitly. A good rule of thumb: keep variables local unless you absolutely need to use or modify them globally. This helps keep your code clean and manageable. Lambda functions. Lambda functions are Python's way of saying why write 5 lines when one will do. These are short on one line functions without a name defined using the lambda keyword. For example, if you want a quick function that adds two numbers, you can write lambda x comma y x plus y. That's it. They are often used with functions like map, filter, and sorted to apply operations to lists and other collections. While you wouldn't use lambdas for complex tasks, they are great for quick jobs that don't need the overhead of a full function. Recursion. Recursion is when a function calls itself to solve a smaller piece of the same problem. Sounds confusing? Let's simplify. Imagine you want to calculate the factorial of 5, which is 5 into 4 into 3 into 2 into 1. A recursive function would solve this by calculating 5 into factorial of 4 and so on until it reaches 1. The key is to always include a base case. This stops the recursion. Without it, the function would keep calling itself forever, leading to a crash. Recursion is elegant and powerful, especially for problems like tree traversal, file systems, and mathematical puzzles. Introduction to file handling. Now let's talk about file handling. In real-world applications, you often need to read data from a file, like a list of users, or write data like saving user scores in a game. Python makes this easy with the open function. Once you open a file, you can read or write data depending on the mode you choose. File handling is essential for data science, web apps, and pretty much any application that needs to store or retrieve information beyond the screen. Let's see how it works. File modes. When you open a file in a Python, you need to specify a mode. The most common modes are R for reading, W for writing, and A for appending. If you open a file in W mode, be careful. It erases the existing contents. Use A if you want to add a file without deleting anything. There's also RB and WB for binary files, useful when working with images or audio. Text mode is the default, which is fine for working with documents. Picking the right mode ensures your file operations go smoothly. Let's look at reading and writing in action. Say you want to store a message in a file. You would open it using open of file.text, W. Write your message with write and close it. Then you can reopen it in read mode using open of file.text, R and use read to get the contents. Python also provides readline function to read one line at a time and read lines function to read all lines in a list. These methods are super helpful for processing data from files like logs, user inputs or configuration settings. Using with statement. The with statement is a best practice in file handling. It ensures that the file is properly closed after you are done with it, even if an error occurs. This is known as context management. Instead of manually opening and closing files, you write something like with open of file.text, R as file and then work with the file inside the block. Once you exit the block, Python closes the file automatically. This keeps your code cleaner and reduces the risk of errors related to file access. Useful file methods. Python provides a rich set of file methods to help you work efficiently. We have already seen read and write. There's also seek, which lets you move the file pointer to a specific position. This is handy if you want to overwrite or reread a particular section of the file. Tell shows the current position of the pointer. These tools are essential when you are working with large files or need precise control over file content. By mastering these methods, you will be able to read and write files with ease and confidence. Let's wrap up. In this session, we learned how Python functions help us write modular, reusable code. We explored built-in and user-defined functions, arguments, return values, lambda expressions, and recursion. Then we transitioned to file handling, an essential skill for real-world applications. You now know how to open, read, write and manage files safely using the with statement and various file methods. Whether you are building a calculator, a game or a data processing tool, these concepts are the foundation. Thank you so much for watching. If you found this video helpful, don't forget to like, share and subscribe to